This video is absolute bombshell because this is for the first time when there is a deployed more ARM servers than AMD's or Intel's, and this is really serious situation. If you watched some older video about instruction set architecture, in this video I explained how ARM architecture is actually really good and much better than x86. And I was predicting that the x86 will actually die in probably 5 years, and the big annihilation will start. ARM will annihilate x86 in 2 years from servers. But actually, this report from cloud server is actually showing that the annihilation starts actually right now. And this is much sooner than I even expected. But let's take a look at this report. You can find a link under my video, and you can actually see that this is the report from cloud servers. And the cloud servers are roughly 50% of all servers deployed. So it's pretty important number actually. And we can see here that there is a pretty massive deployment of the Graviton. And Graviton like a 20% in August and 53% increase in July. This is huge numbers increasing the ARM servers. And of course, Graviton 2 is just specific only for Amazon Cloud Services. So this is actually, and you will see how the Graviton 2 only exclusive for Amazon is actually changing the numbers for the worldwide cloud services. And yeah, because the numbers are incredible. This report shows us some pretty interesting graphs, and we can see here massive increase in Graviton. They increase from 0.6 from March to June. From 0.6 they jumped to 2% world cloud services. And it's also not only Amazon, this is also the Google Cloud Services and Microsoft Azure. So this is a huge jump, and you can see it was bigger jump actually than AMD did. And again, there was a huge jump for August here. You can see from 2% to 3% actually, and AMD went down actually here. And it's not like AMD was delivering the systems, just Intel and ARM Graviton was delivering more systems. So actually there was a gain. Actually Intel went also down here. So you can see, so the Graviton was deploying so many ARM servers that it was actually eating AMD and also Intel market share. And this is really interesting, and but it doesn't show us the numbers, how much. This is like a total numbers of the servers, but it doesn't show us the new servers deployment, which is really hidden, and we need to calculate. And actually we will do calculate from the graphs, and it's actually possible. Especially we will take this graph and we will calculate yeah, the numbers, because we know this is number thousands of delivered. Here we have total numbers, and we have also the percentage share. Even it's not really accurate, there is some rounding, but we can something really nice numbers to take. And you can see here, this is just the Amazon market share, and you can see this is massive, from 1% to 10%. This is huge. It's like it was like a 9% growth, and AMD did also 9% growth, and Intel lost a lot of percent. So you can see there was a massive deployment of AMD servers and even bigger deployment of Graviton 2 servers. And this is really massive. And this is really beginning of the end of the x86. And I will explain why. Another important thing is here. You can see there is a lot of still using Epyc 1 servers and pretty massive deployment of AMD Zen2. But you can see here it was deployed since February. This is pretty, the Zen2 was mid 19 Ryzen, but the servers started to deploy somewhere here, and then there was some problem. There was a lot of months nothing, and then some massive deployment since February and March. So, and you can see there was also the deployment of Graviton started here in June. You can see June it started here, massive deployment, and so you can see June is here. So you can see June Graviton was here and AMD is February. Well, it was already rising, so somewhere here. So there is a 1, 2, 3, 4 months delay for Graviton 2, and it's not much actually, because it looks like the Epyc 2 ROM has maybe some technical issues, who knows. But the difference only 4 months between Graviton 2 and Epyc 2, it's pretty unexpected. And so let's take a look. There is also Intel servers, and you can see there is a lot of Broadwell, Skylake, and Cascade Lake. All of them is 14 nanometers, and even Haswell. There is a lot of Haswell servers. Not much Sandy Bridge. It's like dying. That's going to be probably replaced soon. So this is really important. But let's take a look on the numbers. So we can see here the total numbers of the delivered instances here. And we can actually take those numbers and apply those. We can apply those percentages and calculate actually the number of the delivered servers. So you can see here, I just I filled those total numbers delivered. Of course, it's plus minus, it's rounded. And I filled also these percentages from here. You can see the Graviton is 3% here. So yeah, AMD is here 10.8% and Intel 84.3 is here. And those are the calculated numbers. You can see this is really interesting. And from those numbers delivered, we can do actually, this is actually increasing. This is not the delta. We can calculate the delta, the increases, how many it was delivered every time period. And you can see pretty nice and surprising numbers. You can see here, ARM Graviton here is delivering almost the same number of the servers like AMD here. And this is worldwide. AMD is delivering to all customers. And this Graviton is only Amazon. So this is huge. So I was really interested how is the percentage distribution just for the Amazon, because the Graviton 2, the ARM server CPU is exclusively for Amazon. So it's kind of unfair to compare like a worldwide when the Amazon is manufacturing those CPUs only for themselves. So let's see what will happen inside the Amazon cloud services here. And if we take we know the distribution of the percentages around it, of course, but we can do the same calculation here. And from those, because we know the numbers of the Graviton in total, because we know this is exactly those 10%, so we can calculate the number of the delivered instances here. So we can see here that they really delivered this number, and we can calculate AMD delivered only 540 and Intel only 250 systems. So you can see here that if we do the calculation of the percentage, the ARM has a more than 50% here. And I will just mention here that if you summarize all those numbers, it actually doesn't match 100%. You maybe noticed, because this is like there is a rounding of the percentage here, was the first rounding, and there was also rounding here. So this is like an accumulated double error. So the summary of the percentage doesn't match actually. And you can see also this number is not matched, because this is the delta of those numbers, but it doesn't match the summary of here. So you can see there is some pretty huge error, but it's clear that ARM servers is going to, for the first time, really outnumber of the x86 CPUs actually. And this is a huge game changer here. So let's take a look on the technical, what is the Graviton 2 based? And actually it's based on Neoverse N1 core. And well, this is the AMD, and we can jump here. Yes, so this is the Neoverse. And so Graviton 2 is based on Neoverse N1, and it's a 7 nanometer manufactured on TSMC, and it's based on A76. And let's take a look what is the IPC for A76 in my table. And the IPC of Cortex A76 is actually here. So this is the IPC of the Cortex A76. This is the cell phone core, but there is no not big difference according to N1 actually. And the first server platform was here, the Cortex A72, which is the Raspberry Pi 4 CPU, which is kind of weak. You can see the IPC is really like a half of Zen1, or slightly better than half in Zen1, but approximately half of A76 or Zen2 here. So it's not so Cortex A76 is pretty good CPU actually. Huge advantage of this Graviton 2 is how this Neoverse and ARM cores are really small. You can see it here, 1.4 square millimeters. When we do calculate and kind of estimate the die size, yeah, we need to, because the Graviton 2 is actually 64 core, it's probably the biggest monolithic server core on the world, probably, so don't forget this. And so it's probably 90 square millimeters, which is not bad actually, it's pretty small. And L3 cache, I'm taking 32 megabytes on the Zen2 chiplet is approximately 35. Yeah, on this ARM chip could be less, but let's take the bigger number. So it's roughly 124 square millimeters. But there is a huge portion, huge area on this chip is actually the I/O, the memory, 8-channel memory, DDR4 controller, and PCI Express 4.0. There is a lot of lines. Even there is a less than the Epyc, but let's take a Epyc. Let's scale the Epyc I/O die, which has a 416 square millimeters, manufactured on 14 nanometer global foundry. And let's scale it down to 7 nanometers. Actually, it's 2 nodes, and we know that there is each node is only 20% is scaling down the analogs, and so the 2 nodes has a 1.2 power 2 is 1.44, and we will get for the IOs pretty huge, almost 300 square millimeters. So we can actually, when we do summarize this means the total die size, the estimated die size here for the Graviton 2 is pretty huge, 413 square millimeters. But you have to remember the Epyc, the ROM, has a 1005 square millimeters. So it's more than twice smaller, this chip. And it's delivering pretty high IPC despite being really small. But how much does it cost? 400, it means like a pretty huge chip, right? But we know that the Radeon Vega 2 or Radeon 7 GPU has approximately 350 square millimeters, and it costs, when it was new, it was $700. And of course, the minus margins, memories, PCB, VRAMs, and all silicon could be probably around 200. Just this is really my rough estimation. And if we take it 200 and we will linearly scale it for from 350 to 413, which is really close to the GPU, we will get the estimated cost 235. I have to say here that probably there is a, the yields for the bigger chip would be probably a little bit lower, so could be 250 maybe here, but it's still $250 for such a huge server grade CPU. It's really cheap. And you have there is probably licenses cost. I don't know how much is it. Probably not that much, but biggest portion is probably the Annapurna engineers, which actually they do all the work. So my rough estimation, it could be like a $500, right? When they make a lot of thousands or maybe 1 million of the CPUs, it could be something like $500 in total. So it's really cheap. And don't forget, 60-core AMD Epyc cost $7,000 US. This is huge. This is like a huge difference. $500 versus 7,000. And even Epyc is delivering slightly bigger overall performance. It's not, but it's not much, not that much, to actually to have like a 14 times higher price. But there is also, the memory and the motherboard and the SSDs. It costs like a 5,000, 7,000. And so you can see the price of the CPU is pretty, it's for the ARM is like almost for free. It's really the cheap in compared to Epyc. And we know that Amazon is offering the price roughly 40% lower price per same performance in compared to AMD. And this is huge. This is why only 40%, even the price is like way cheaper, because really for the ARM servers, the majority of the cost is the memory and motherboard and SSDs. So you can see, it's almost for free, this CPU, and this is huge, and it's delivering almost the same IPC. But let's take a look also on the numbers. Let's take a look on the architecture also. We can see here that Cortex A76, which is also in the smartphones, we can see it's pretty good. It's like 3 LAUs. This is kind of Nehalem Sandy Bridge, great, but it has this one pipeline for the branch. So it's a kind of 4 wide. So the execution course is really wide, the same grade like Intel, Skylake, and also Zen and Zen2, because Zen2 and is also 4 wide, even has a 4 LAUs, but this special branch is most of the time is utilized with the branching anyway. So that's why it has a slightly lower IPC than really true 4 LAU CPUs, but this design is really nice and it provides pretty high IPC. And you can see here, this is also the floating point. It's pretty good. It's a multiplication and addition for both pipelines. So it's really equal to Zen1 in terms of floating point, because this is 128-bit wide neon units. So this is really similar to Zen1, which is also 128-bit wide floating point units. So it's just in 4 pipelines, but there is a sparse, there is a 1 multiplication, 1 addition. So it's a really similar design. And also the memory units, it's really similar to AGUs for the load store, really similar to the Zen1. Zen2 has a 1 address generation units for the store here. So it's a little bit better than Zen2 in the memory units. But let's take a look here. And this is the pricing. This is from the Anantech, and you can see the pricing, the performance, actually the performance per $1. Throughput per $1. You can see this Graviton. Depends how big, how many instances you are running. But you can see the spec 2017, the benchmark in the integer, it's really delivering more than double. That's why there is a price minus 40% in average. But you can see it's the economy is huge. It's like the same performance, you are paying less, you are paying almost half the price. This is huge, and everybody is searching for 5%, 10%. You know, Intel and AMD is there, like who is 5% higher IPC, who is 3% cheaper, 10% expensive, you know, and ARM is offering half the price for the same performance. This is huge. This is why actually x86 will be annihilated by these ARM servers. And Amazon is starting, is to be the first which is starting to do this. And in terms of performance, you can see here, the Graviton 1 is pretty weak. This is the Cortex A72, and you can see, and remember, this doesn't have a SMT, so this is like comparing Epyc, Zen1 Epyc here with the SMT enabled. Normally, without SMT, it would be somewhere here. But SMT brings some 20%, so it's like so yeah, but you can see that Graviton is, the Graviton 1 with the Cortex A72 is really slow, but this A76 is faster actually than Zen1 in the IPC, and also Intel. Intel is running higher frequencies here. But you can see, yeah, it's destroying Zen1 Epyc and also Intel systems, and in both in the integer and also in the floating point, you know, in the mathematical calculations here. So this is the strength, you know, it's a huge thing, because and they deliver bigger performance for half of the price. Actually, this is already actually it's like delivering bigger performance for the same price, like a twice bigger performance for the same price. And this is huge actually. And but why the annihilation started right now with the Graviton 2? Why the annihilation didn't start with all the promises with the other ARM servers, beginning Graviton 1 beginning with the AMD A1100, the first servers from AMD, and later on was cancelled. And also, while failed also the Thunder X from the Cavium and the Sia Micro and the other companies. And actually the answer is here in the economy. And you will see here the fixed cost for like a $5,000 for the memory and the motherboards and the other things. This is really the same for the x86, AMD, Intel, and also for the ARM. And even you will save, you will manufacture your ARM CPU really cheap. This cost is really dominant. So you can you can save like a 50% from the cost of the whole server. But if you deliver only 25% of the performance, so the savings is actually not worth, this. You will save 50%, but you will lose 75% of the performance. So this is actually the answer why all the previous attempts for the ARM servers it's ultimately failed. It was the economy problem. And the Graviton 2 is the first CPU which delivers similar and even higher IPC, the similar IPC, but because there is no SMT, so single thread, the performance per thread is higher than x86. This is for the first time. Then the savings actually is there. It's actually the first ARM server CPU which actually saves the money. And because there is a fixed half of the price is in the motherboard and memory, as you can see here. And when we go to the performance numbers, you can see here that the first Graviton 1, which has a A72, is really half IPC. Then when you have to fight with a Comet Lake or Ice Lake or Zen1, the half IPC doesn't help you because you save half of the price for what? But for the half of the IPC here. So you will get like a no savings. You have the same performance per dollar like Zen1, and you have a different instruction set. So there is even more complication with so people are not motivated to. There is no savings actually. There is even more work to migrate to ARM instruction set. So it's actually not really worth. But since Graviton 2 has an IPC here, it's a higher IPC than Zen1, and actually you are saving 50% on top of it, then the economy starts to work. Then you are going to save 50% instantly. And this is a really important lesson. This is the economy which is behind. That's why the N1 will really start to destroy Zen1, all the Comet Lake, Cascade Lakes. Also Zen2 is really close. And even Zen3 will have a problem. And Zen3 will be more expensive per the same performance than A76. Because you are saving 50%, so it means Zen3 must be somewhere here to have to attack the ARMs here. But because it's not, it will be still better to use ARM servers. It will be cheaper per performance than Zen3. So yes, this Graviton 2 will really attack also Zen3 systems. So it's not, it's a really serious situation for AMD and Intel. And what about this server V1 core? Guys, what about this V1? You will manufacture this core for cost of the $500, and you will have a much higher IPC, much higher performance than Zen3 for $10,000 because AMD decided to make it more expensive. So we're going to pay $10,000 for such a low performance. when everybody can buy a license and manufacture for $500 much much stronger CPU. You know, it's like a it's really crazy. It's like a 20 times cheaper and like a 30%, 20% higher IPC, guys. This is the annihilation when it starts. The V1, then there is a Matterhorn. The N2 is equal to X1, X2, and then is a Makalu. And don't forget, Makalu is one of the highest mountains, and it could be somewhere here, and it could be somewhere here actually. This is my range for the Makalu V2 core, and guys, this is the end of x86. If you are watching this video, you should remember that this is probably the first YouTube video that is suggesting and kind of predicting the end of x86 CPUs. And it's just based on the economy, yeah, because if Zen3, Zen4, I mean, they need to deliver much higher IPC to be economy, to be the x86 to justify the higher prices, but x86 actually cannot deliver that performance. Actually, they was delivering the higher performance here with the Zen1, Zen2, Intel, Haswell, Ivy Bridge, Sandy Bridge. This is really high level. This is really nice IPC in compare to Cortex A72, A57, all the 32-bit. Yeah, the old ARMs was somewhere here. All the attempts is somewhere here. So the Intel was delivering double performance, double IPC. So they can ask like a $10,000 per CPU, but not today when they are delivering the same IPC and even a higher IPC. Guys, this is the end of x86, and it's based on the IPC and the economy. And the economic model of the ARMs, which everybody can buy a license and manufacture their own CPU. This is really something which we really, this will kill the x86.